Hello everyone. Today I invite you on a journey that blends the wonder of our inner lives with the precision of mathematics and physics. Imagine time not simply as the ticking of a clock, but as a dimension that can be transformed and understood in deeper ways. In certain theories of special relativity and quantum mechanics, scientists use a process known as a Wick rotation, which transforms real time into what we call imaginary time. This transformation involves taking a period of time, traditionally represented as t, and multiplying it by a special number, the imaginary unit, so that we get a new time coordinate, often called tau. Although the term imaginary might suggest something unreal, it is simply a different way of expressing time using numbers that include the imaginary unit. To explain further, the imaginary unit is defined by the property that when it is multiplied by itself, the result is -1. This idea is the gateway into the world of complex numbers, where a combination of a real number and a multiple of the imaginary unit gives us a complex number. When we apply this concept to time, we obtain a new coordinate by saying that tau equals the imaginary unit multiplied by t. One can visualize this as a rotation of 90 degrees in the complex plane, a transformation that is both mathematically precise and physically revealing. In Einstein's theory of relativity, our universe is described as a four-dimensional spacetime, where the familiar distances of space and time are unified into a single interval. Normally, this interval is computed as the sum of the squares of the three spatial dimensions minus the square of time. However, if we multiply the time coordinate by the imaginary unit, the expression for the interval changes. It becomes the sum of the squares of the spatial distances plus the square of the product of the imaginary unit and time. In other words, by defining time as an imaginary number, we write the interval as the sum of the squares of the spatial dimensions plus the square of tau. This adjustment is not just a mathematical curiosity, it has profound consequences. It smooths out the harsh singularities, such as those associated with the Big Bang, by allowing a continuous, boundary-free description of the universe. This approach isn't confined to relativity alone. In quantum mechanics, the imaginary unit plays a crucial role. It appears in the fundamental equation that governs the evolution of quantum systems, ensuring that wave-like behavior and interference patterns emerge naturally. This is the same imaginary unit that, when applied to time, helps to preserve the mathematical consistency of our theories. Stephen Hawking, among others, used these ideas to propose models of the universe where the Big Bang is not a violent singular beginning, but rather a gentle, continuous transition. Such models invite us to rethink our ideas of beginning and boundary, challenging the very labels of real and imaginary that we often take for granted. When I consider these ideas, I feel a deep connection between the abstract beauty of mathematics and the way we experience life. Every heartbeat, every moment of quiet reflection, is part of this vast, interconnected tapestry of time and space. Imaginary time reminds us that our common, linear perception of time is only one way to look at reality. There may be hidden layers and deeper structures underlying our everyday experiences, just as the rigorous mathematics of imaginary time reveals new facets of the cosmos. The process that transforms time mathematically is not far removed from the ways we sometimes transform our perspectives in life. By shifting our view, we uncover new meanings and possibilities. This blend of rigorous science and personal reflection shows us that the universe is not a cold, detached mechanism, but a living, dynamic entity full of mystery and beauty. The mathematics that underpins imaginary time is precise and demanding, yet it also offers us an invitation to experience the universe in a more profound, holistic way. It is a reminder that the most abstract ideas can have tangible, transformative power, not only in explaining the workings of the cosmos, but also in enriching our understanding of our own lives. Thank you for joining me on this journey. If you found this exploration both intellectually stimulating and personally meaningful, please like, share, and subscribe. Let's continue to explore the remarkable intersection of rigorous science and the human experience together.